Woke up this morning, feeling low. Where my loved one used to live, she ain't there no more. Poor me, why such bad luck fall on me?
In 1997, 6 were killed and 18 were infected with avian influenza. In 1918, a similar virus killed as many as 100 million people. This small outbreak could morph into a pandemic.
Avian influenza, also known as the bird flu, is a single-stranded RNA virus. Its main proteins are hemagglutinin and neuraminidase. This virus is usually transmitted just between birds, but the real danger for us is that it can mutate into a virus that can be transmitted between humans.
The virus has 8 single-stranded RNA genes. They are surrounded by a lipid, or protein, bilayer. Then the 2 main proteins, hemagglutinin and neuraminidase, stick out.
There are also different types of the virus. The most dangerous strand that is going around now is the H5N1. The H stands for hemagglutinin and the N stands for neuraminidase. The numbers stand for the specific type. There are 13 possible types of hemagglutinin and 9 possible types of neuraminidase. These 2 proteins are the 2 proteins that the body's immune system recognizes, and they can change with the virus and the virus will still live. Then the immune system cannot recognize it anymore.
Kansas was where the deadly strain of the virus first started in World War I. Having a war take place during this time was perfect for the virus to spread. Our soldiers were going overseas infecting Europeans. Cramped quarters for the soldiers made the spreading of germs easy. In the beginning, even health experts didn't think that the flu was going to be much harm to anyone, and told the nation not to worry. Little did they know that the virus would turn into a world crisis.
Soon the disease started rapidly spreading, and towns went under quarantine, realizing the seriousness of this flu. There weren't enough hospital beds for people, and the country was in panic. Now, in the 21st century, we realize the danger of the virus attacking again. But does that mean we're doing anything about it?
Scientists are watching those who are infected by the virus, and making sure that they know where it is so they can keep a close watch on it. Also, the process of making vaccines is being sped up. They used to make vaccines out of chicken eggs, and now vaccines are being made out of cell cultures. The first clinical trials for a vaccine began in April of 2005. A cell culture is the process by which either prokaryotic or eukaryotic cells are grown under controlled conditions. We do have some vaccines for avian influenza, but the virus keeps on mutating, and these new mutations can be resistant to the vaccines that have been developed. Farmed chickens that are infected by the disease are now being killed. In Washington, already $5 million has been paid by the federal government for the research of the avian flu virus.
It is useful to see how immune system cells act when combating viruses. To study this, scientists look at immune system cells and viruses through high-powered microscopes. David Cole, a Seattle virologist, will show us what important cells in the immune system look like.
And the cells I'm going to show you now are the cells of the immune system. So these are some of your body's defender cells that we also mainly study in the lab, called lymphocytes. And we're growing in these little dishes, and this is the name of and code number of the patient. And we've actually put some vaccinia. Now that's the smallpox vaccine, so VAC stands for vaccinia. We've actually put some UV ultraviolet-killed vaccinia in with these cells. And I'm going to show you here. These cells are rapidly having babies. They're going nuts. They're replicating. And I'm going to give you a feel for that under the microscope. All right. So again, don't be a high-power junkie. Don't immediately go to high power when you look under the microscope, or you're a loser. Okay. So go ahead and look under here, and you'll see some little tiny dots in the distance. See if you can, I'm just going to move around a little bit. Some of them are round, some of them aren't, and a lot of them look like they have a little protuberance sticking out, like a little arm sticking out, where they kind of look kind of bowling pin shaped or something. And those are lymphocytes. Those are the cells of the immune system that can either make antibodies, or there's other cells called T cells, like CD4 T cells, the HIV. There's a good one right there. Those are the cells that HIV can attack, for example. But in here we're studying them because they're helpful in the immune response against viruses. And we're actually growing these T cells. And a lot of biology is observation, and we get a lot of info by looking at these cells under the microscope.
The 1918 virus managed to outsmart these cells. The virus managed to stall the immune system response so that the virus could get a hold in the body. Then it caused an over-the-top immune system response. The response was so exaggerated that the lungs filled with fluid, and the victim often suffocated to death. The immune system hurt the victims, it did not help them. For this reason, scientist Yoshihiro Kawaoka believes that if someone comes down with pandemic influenza today, he or she should take anti-inflammatory drugs to calm the immune system, in addition to drugs that kill the virus.
And just take a look in here under the high power. You can see that this is what's called a phase microscope. And if you get the lighting right, you see the little halo of, that's good, that little halo of angel light. That's what phase microscopy will give you. That tells us it's a living cell. And it almost looks like it has little hairs sticking out of it. And so that's the sign of a healthy lymphocyte. And we spend a lot of time in the lab. It's like you have different species of tropical fish. You're trying a little of this food and a little of that bubbles, and you're changing the pH and the temperature a little bit. Taking care of these T cells is a bit of an art rather than a science. And in this case, we're not so much growing virus directly, but these are antiviral immune response cells that we are focusing on.
But we aren't too prepared for the disease. It has been reported that we only have 14,000 hospital beds in the state of Washington. And if the disease burst out into pandemic, 14,000 beds would not even be close to how many Washington would need. Another worry is that there has been a decrease in the number of hospital beds as the number of facilities and occupancy rates have increased. Many people ignore the threat of pandemic and don't realize the seriousness of it, even though our leaders may understand this. Also, even though we are attempting to find a vaccine for the flu, it's hard to keep up with the mutations of the virus.
And what can the general population do to fight a pandemic?
The time to start remembering to practice good hygiene measures. As I mentioned before, the hand washing, that's critical, the flu shots, those types of things, just those general precautions, not touching our face or our eyes with our hands, things like that. That'll help in your health today, and it may help you with your health tomorrow if there is any kind of pandemic.
Birds infected with the virus spread it by their feces, saliva, and nasal secretions. The symptoms they show are hemorrhages, inflamed sinuses, and death. Humans spread the disease respiratorily, and it can also be transferred from dead people to living people if you are close enough. Symptoms that humans show are high fever, fits of coughing, delirium, discolorization of skin, and death. The current H5N1 virus rarely spreads between humans, but these symptoms are from the 1918 virus. The virus can mutate rapidly, making it harder for the immune system to recognize it. Someone who has previously been infected with the virus can catch it a second time if the virus mutates so it is unrecognizable to the immune system. The virus can mutate when a human gets both the normal flu virus and the avian flu at the same time. The genes of the two viruses mix and create a new virus. China is the country in which humans and poultry are in the closest contact with each other, and so this is most likely to happen there. Also, the virus can simply mess up when replicating itself.
When someone infected coughs and the virus is inhaled by another person, the proteins on the virus latch onto the receptors of a cell in the respiratory tract. Then it goes inside the cell and replicates itself. The neuraminidase cuts all the viruses free from the cell.
There is not a world war going on now, but because people take planes and road trips in their cars, an infectious flu can still spread. In 1918, people traveled much, much less than they do now. An innocent vacation could spread bird flu.
All my life I've been searching for something. Something never comes, never leads to nothing. Nothing satisfies, but I'm getting closer to the prize at the end of the rope. All night see your ghost.